Hello, everybody. Tonight, a couple things to go over. I guess first off, a reminder about the exam. Remember, exams are on a calendar schedule, which is different than the regular homework. It's Sunday through Saturday, so you have until Saturday at 11:59 p.m. to look at it. There was a question about it with something. It looks like there's a project files, but it's a right, we talked about Maven and Ant and Gradle a little. Those are the most popular. So it kind of looks like those, but when you try to open it in NetBeans, it might not work in yours. Somebody asked about that last night, and I tried it, and it worked fine on mine. And I said it still didn't work. So when I looked a little bit deeper instead of just hitting the open button, and it looks like it's packaged to be built with the GNU compiler, which is actually a C++ thing. So y'all probably don't have that compiler on your machine. So I do want to look at something with the exam. We'll look at that. I sent out an announcement about that error at the end of class. Did everybody see that?
Yes.
We've been staring at code for 2.5 hours at that point. I figured I wasn't going to see it, and it was in a completely different file. The thing didn't get copied. That line we copied and pasted into all the constructors. We missed one of the constructors. And it happened to be the constructor we used on that object. So there's that. And then when I was reviewing the videos, I noticed I didn't say what went wrong with Git. Y'all remember how I was talking about the version control and how useful it was, and then suddenly had to retype a whole bunch of stuff? That was just a silly mistake on my part. I didn't save the changes. If you remember, I was like, yeah, we can go back to old versions, made some changes, and went back to the old version without saving the new stuff. So then there was no way to get back to the new stuff. Is what went wrong there. It might not have been, I noticed it wasn't exactly clear when I did the video. But in general, there was a lot of information the other day, right? Abstraction, interfaces, enums, and those are probably new to everybody. So the main thing for tonight is an example. I put together a pizza ordering example that uses all those things in situation. So it's tonight to just kind of follow along the example, and hopefully it'll make more sense seeing it in a situation than seeing those arbitrary theoretical points about it. But first off, a note about the exam. Since we've talked about Maven and Gradle are the two that are most common. Our class example so far, and probably the class example tonight, we're going to use Ant for the packaging build information because it's there's less folders. Ant is in a human readable form, so we can get to our source code. Our source code is only one folder deep instead of like 12. So it's a lot better for examples. But the one that came out with the midterm files you need are it is in a different one altogether. It's in one that's usually used for C++, and it's set up for the GNU compiler, which is very, very popular for C++. So if you've done anything in C++, that's probably on your machine, and NetBeans would have noticed it, which is why when the question was asked about it, it worked fine on my machine. Because I have a GNU compiler on my machine, so it just went ahead and ran. Does everybody look at what the midterm is?
Yes.
I see head nods in here. Yeah, so the midterm is just a debugging assignment. Hopefully straightforward. There are some files to run with it as well, though. And that's where the problem. So the document has a bunch of code, which obviously you're probably going to want to copy and paste that into some Java files to find all the bugs in them. And there's also this project here. This might be where it's at. But if you download that, downloads and unzip the file. So when you download that zip folder, you should be seeing something like this that looks like the projects. We're all kind of new to Java, right? Talk about the package management, the build managers. We use both terminology. Package kind of refers directly to the folder, but we have lots of folders involved in any project. And eventually we need to build those into machine language so they can run. or at least something the machine knows how to work with, not the text files. And that's where all the instructions for that are. These are actually for, so like those top two files there, class path and project, that's all a bunch of XML. If I open that with like, actually I can just do this, can't I? If I open the Sublime text editor with the current directory, I just put Sublime dot in there. I'll start this other video. I copied and pasted. I'm debating on sending this to y'all. You see the name there, seems kind of rude. The guy that won the Nobel Prize in economics last year, some people that work for PBS actually made a really good video simplifying what it is. So really good points. So I might send this to you. There's big fancy names, like obviously before the guy won the Nobel Prize, he put a big fancy name on it. But when he was doing his research with it, he did actually call his research ways people are done with money. And that included the economist, because one of the problems with that economics assumption that everybody's going to make a perfect decision, perfect financial decisions every time, it countered that. But I might send you that video because they did a really good explanation for it. It might be useful. But like this, you'll see the instructions here are in XML code. That one there doesn't seem to be much. It's a whole bunch of stuff here. Org.eclipse.jdt.launching. That's not only what it was using a GNU compiler. You look through those files, what we need, if I expand it, the bin folder, actually, I'm done with the text editor, I can close that. The bin folder has the class, so this is the .class file, the compiled versions. And the source folder has the source code. So really, we just need this part. So what you want to do is copy this into a new project, and then there's one line you'll have to change. So just create a new project, and it will work, or maybe in any of them. I'll just call it Java application 10. Oh, whoops. Let me not do that. What was that one? Let me delete that one. When you create a new project, sorry, one of the main things I was going to point at, I skipped right over. Uncheck the box because those source codes that were downloaded have the main class. So you don't need to create a new main class. You can give it the same name. So notice we're in the project here is called print month 2. So instead of calling it Java application like I did, you could just call it print month 2, and then those automatic names will be correct. Print month 2, do not create the main class, and when you finish, we'll end up with in our source packages, all we have is the default package. There's nothing in there. So over in the file explorer, just grab what's in that source folder and copy it and paste it into the source folder here, which might still require a slight change. So now the default package has the test days. Yeah. So just copy those over and then fix the bugs in them. Once you copy them over, it should be good. Yeah. Copy the file with the main method and then the other folder in one class and keep them in that same structure. That'll be important. And then just go through and fix the errors. But it might be when you create a new project, it's probably a good idea to go ahead and give it that name. Okay. I just wanted to make sure it copied over correctly. Like here, notice the error on the package name. Or if you haven't seen it before, in NetBeans, when you have that light bulb with the error symbol, this will be helpful. You can just right click and it'll tell you how to fix it. Or not even right click, sorry, click on it and it'll tell you how to fix it. So once you get into NetBeans, all the stuff should be fairly automatic for fixing it. I don't know why I just closed NetBeans because we need that for our stuff. That makes sense to everybody? This is the wrong compiler. In most likelihood, you only have a Java compiler right now not a C++ compiler we're gonna make work for Java. Because Java is really just cleaned up C++ code. So now our example. Leave that one. So hopefully the midterm's not too bad. The new statewide course shell, which I decided not to use because they were using a GUI package, and I complained about a bunch of things, and they went ahead and applied most of them, so I just kind of let the GUI package go. It's like, well, I just want to do it in class. But it's a GUI package that was removed from the language 7 years ago. It was deprecated in January 1st, 2018.
It's a teaching system.
GUI packages are out of date. They removed it. Software development industry had stopped using those built-in custom GUI packages for years before languages all removed them. Only Python still has one built in, and that's because part of the way Python was built, everybody's seen Python. tkinter does not depend on Python. Python depends on tkinter. So they cannot remove it. They're the only ones that have a language left, and they really, really want to, but they don't have the original source. I don't think anybody has the original source code of that. Otherwise, it's going to frameworks like we'll see in this class. Or other types of interfaces. There's alternatives that work better, cross-platform things. With the GUI packages, we usually have to do something it has to be unique for every system we run it on. So our example here, I drew out a diagram to get us started about what we're going to do. A pizza ordering app is going to apply a bunch of things, and I never use these cameras, so let's see if I can use this correctly. Oh no, that's microphones. Camera. I'm guessing it's this one. Yeah. All right, if you put it on speaker view, you should see that. That looks like that. Nope, that's
Oh, it's upside down. Yeah, it's mirrored.
It's because it's a self camera, so I don't need to mirror anything to see.
This camera should be here. Video settings. Oh, okay. There we go. I'm gonna spin down here. Don't have a problem tonight. So, also tonight we will see what a main class typically looks like in Java. The stuff we've been doing, the textbook examples and tutorial examples, if you go check it out on YouTube, they do not give a good preview of what example looks like. Ignore this black line, I scribbled that out. So our main method's down below, but we have an abstract class, which it'll have more methods, but there's at least one abstract method with method in it. It's going to be abstract. It's pizza ordering, so we have for an enum just the types of crust because that's a finite list. In our case, it is a short list. Perfect for an enum. We only have so many crusts we're going to deal with. Then we'll create an interface called pricing, and that's what that black line was supposed to be for at first, and then decided this would be better. So that dollar sign represents the interface. You can see that abstract class pi, it has some child classes for the specialty one, like Supreme, meat lovers, pre-built one, or the custom one, right? Just call it pizza place and say I want a pizza and list out what toppings you want explicitly. And that dollar sign shows up again, so the custom is showing up here. Or I guess in the picture, the specialty, either a pepperoni pizza, a cheese pizza, or sausage pizza. That seems simple, like it would fit in a classroom, but hopefully you can see the obvious extension from there as well. Other specialties might be supreme. Maybe instead of sausage, we'll do a supreme. That would make more sense there. That way we're not overwhelmed in class, but does that picture make sense to everybody? Watching it on Zoom, are you able to? Everybody doesn't know how to make that full screen on your Zoom, right? Go to speaker view and double click on it. You should make it, should be able to see it in full view. I'll leave that up in case so we can refer back to it. If you want to, you can take a screenshot of it or something, but I'm going to leave that camera on so we can refer back to it. And I'll go ahead and share my screen over here on the laptop. So we need to make that would be a class. Bless you.
Thank you.
A whole bunch of things. So we got to worry about how to organize those. So obviously, I go back to that real quick. Another thing about that, it's just the UML class diagram, and notice we don't really have enough information. UML is like that. It's an international language. It is a language, just pictorial instead of phonetic. So we draw the pictures, but the pictures are like words. One word isn't enough to convey meaning. We need a whole sentence or a whole paragraph. So normally we need lots of UML diagrams. Like this tells us the classes we need, tells us what's abstract. In your class diagram, the hash symbol represents abstract. Underline things that are static. Y'all think like fancier class diagrams. So I also like to show that because the book is full of really nice looking formal class diagrams, which aren't very useful for collecting our thoughts. It takes a long time to put those together. Normally we'll do something like this. Just jot it down quickly and get the idea there. But it's only one UML diagram, so we don't have the full picture. Like we don't see how to organize that. So we will need to choose some organization things. I have my other machine pulled up from doing this example last fall, I guess was the last time I did it. So I'm gonna create a new project. I'm gonna go with an AMP package again, just because that works nice in the classroom. But like we've talked about before, you probably want to use Maven or Gradle. If you know it's going to run on a server, you want to go with Maven. If you know it's going to run on something with an SSD drive, probably be better to go with Gradle. That's not a restriction. All of them, any of them can work for any machine. It's just obviously a server with a spinning disk, a centralization is better because then we only have to move the read head once. And with an SSD, the distribution is better because with a solid state drive, we can pull from lots of different spots simultaneously. Pulling lots of small things is better than pulling one large thing. I'm going to uncheck the create main class and I'm going to call this pizza. That sounds like a good name for it. Hit the main class. We're not going to import any libraries right now. So finish. And we'll have to sort of create all of our stuff. I guess we can go ahead and create a main class. I want to do it here. I'm going to put everything into a folder called pizza. So if I just start doing it right here, put right in the source folder. So I'm gonna click on source packages and right click and create a new folder. Everybody see the buttons for that? Starting to get used to NetBeans a little bit. I'll just call this pizza with a lowercase p because that's sort of our top level package name. We can have multiple folders in the package. Now we can create some source code, maybe the first one, a new Java class. If you right click on the folder you want to put it in, that's usually the best idea. And should see Java class on the short list. If not, you can go down to other and it has recents, so it should be under recents. Those we create all the time. So I'm gonna create a new Java class. The default one, I'm just gonna, our main method, I'm gonna call pizza. I guess I could call it pizza main and get all this stuff out of the way. Well, we know this is gonna be the main method, so I'm gonna go ahead and add public static void main. We've talked about all those keywords a few times. They're always the same, right? And Java 21, which the long-term support version, the current version of it is in beta test and is scheduled to become long-term support on September 24th. This is always the same, which means the compiler could type that. There's no need for a human to type something that's always the same. That's what computers are great best at. Right? Public static void main and accept an argument of strings. A array of strings, traditionally called args. This is the only word we're allowed to change in our main method. The plagiarism checker built into Ivy Learn goes crazy with y'all's work in this class, by the way. It's like, oh, public static void main is plagiarized from everywhere. It shows up in like every Java code. It's hard to say where it's even copied from. We'll come back into the main method. And in particular, this main method is going to look a lot like a more typical Java main method than what we see in the class. So I think I'm going to start at the top right on the picture. Let's make this interface. We need a way to make sure we can plug things together and they're going to work. A connecting point. If it helps to think about the physical hardware, which I just lifted that up, that the main camera's not on. Think about like a USB port, the shape of the USB port. We need to make those shapes so that these things, we know the pieces of our code will plug together and work together correctly. That's what an interface is. So we'll start with that interface. I'll put it in the pizza package again. So right click and a new one. And if you followed along the other day, interface should be on the short list or the recents list. If not, just go down to other. And it's a Java thing. So the one right underneath the class, just a new interface. And I'll call this pricing. Because that's what I called it when I drew the picture. Maybe I can do that. Instead of constantly hitting stop share, why don't I do what I suggested and take a screenshot of that picture? There we go. And then I believe I can right share my screen and just pull up that picture instead of constantly going back and forth. Which means I can probably turn this one back to the other camera. Is it okay if I turn this back to the room camera? By saying no, so I will turn that on. So this public interface, call it pricing, and I should open that picture so that we can just look at that. Okay, that's probably much easier than constantly going back and forth. So what does this need to do? Well, according to the preliminary plan, it just has the interface, the rules that govern how our software connects together, different pieces of our software together, is that we're going to require a method called calculate cost. Which you can see over here ultimately goes with our toppings. So we have the base price, could be based off the crust. Could just have the base price overall, same for all the different crusts, but probably based off crust. I think we'll have time for short selection structure. And then each one of our toppings is going to have a different price. So we will add, so the toppings are what's going to actually apply that method. But for now, we just kind of set up the rules. There's going to be a public method that will return a double because it's money, called calculate. But it's an interface, so we don't need to write any code. We can write code, but for clarity in the classroom, let's go with what Java was until like just a couple of years ago and say no code in an interface. That's a fairly recent addition. So that's the rules things have to follow in order to be part of our program. Somewhere in there, whether it's in the class where you're defining itself or in an instance created, an object that we're using in that class, something in our code has to have that method. That's the rules, the requirements. And that's all we'll need for the interface. If you like analogies, think of a USB plug. That's the shape of the plug that holds our pieces of software together, that connects them together. Go to place order yet? I'll come back to that one. And we need to start putting together some things for our pie. So in the picture, we have this enum for crust. So we need to set that up. And there's going to be lots of types of pizza pie, right? By default, there's going to be the meat lovers pie, which I think is a trademark name. So we'll have to call it something different. But the supreme, the fully loaded down one with everything, there's going to be lots of types of pie. So if we put them all in the same folder, it might start to get a little bit cluttered. So I'm going to make another folder inside of pizza here. So sort of a sub package. So a new folder, and I'll call this pie. And it'll have all the things like the types of crust we have. So an enum for our crust. That seems like a good place to start. So in that folder, right click and select new. I keep right clicking right on it. It also works. Make sure you select, if you select the folder first, then the new button up here works. Just make sure you select the folder first. Otherwise, it could very quickly end up in the wrong thing. So with that folder selected, I'll hit the new button here and create a new Java enum. This one doesn't have a short list, so we only see the full list on this one. But notice the order it comes in, enums are the third one down. So that's not an arbitrary order, and you'll quickly notice that it's not in alphabetical order either. So it is the things we're most likely to use, more likely we are to use something, the closer it is to the top there. In the picture, I called this crust. I guess I can point you the picture. So this is an enum of crust, and we can have thin crust, deep crust, tossed crust, or the gluten-free crust. Seem like some good options. And this is just the short list, sort of restricts us to certain things, and it makes our code look nicer is the biggest deal with it. In some languages, we can do math with it. Not Java, we can't, but in C#, we can do math with it. So like the first one would be a 0. And then the second one would be a 1, deep dish. And they're typically constants, so they're all uppercase letters following that convention. Uppercase with underscores where it's fully spelled out. And C# and C++, we could do math with them, like it's 0, 1, 2, 3, but they did block that in Java, and we just have to treat them as non-numerical options. Like we saw the other day, we use them as items in a switch case, or an if else, or gives us definitive values and makes our code look better. Might be a good starting point for that. I guess we could have hand tossed or gluten-free. I have to eat gluten-free so that everyone makes it out on this. Otherwise, I might start thinking about pizza and make myself sick by getting a regular pizza on the way home. Okay, so there's the types of crust we have. So it's a short list of items we could use. And notice how there's not much going into any particular file. We're not writing hundreds of lines in each line. We want to minimize what's in each particular object. That's something we're not going to focus on much in this class. I probably won't say it beyond this one little pause right here, but it is something you want to minimize. Lots of classes will always be superior to a big class with lots of items in it. Like we talked about with the Gradle packaging, or just think about computers in general. The ones in the zeros, it either does something small or it doesn't do anything. So lots of small things is always better for the machine. So far we have 2 things that have 1 line. We'll get back to this one soon. There's not going to be much there. And most of our stuff is going to look like that. That's where inheritance comes in really useful. Look at pictures, we continue around. So the interface, we got our enum, our interface. The next thing is this abstract class, which is the parent of all of the classes we're going to use. This picture looks a little bit off. I drew the same arrows everywhere. Green. This arrow should be a dashed one for a dependency. If you haven't seen that, the way we draw the arrows means something different. And when we get down to placing an order depends on our pi class. So it's we have a dependency there, which should be a dashed arrow, but I wanted to highlight the UML class diagrams in useful format, not the fancy thing that we see in books. To get that fancy one, that can be generated. Once we write our program, it doesn't take any thought to put that together. We'll look at a couple generators for those later. So the UML class diagrams, really nice looking ones, the computer can write that for us. If our program's already made, it doesn't require any more thought to draw the picture representing. So next up is our pi class. I'll select the folder and then use the new button. Do that a couple times. And we need a class here, which is the parent of all of our actual pizzas. So I'm going to call it pi. That seems to make sense. Get all this stuff out of there. Those links at the top, we really don't need those at all. That's fairly new. When did that come out? That just came out in 2020, and instead of giving you the ability to edit your templates in NetBeans, in 2020, I guess people at Apache were really bored or something. Somebody was really bored, and they made like 50, 60 templates so that you can go download and choose the template you want instead of editing the template yourself. That's what those links are. So if you click those, you can go find better templates to start with. I just haven't changed from the default one. So pi, but we know it's going to have our interface. So there's no parent class, so extends another class or implements an interface. We have an interface, so we want to implement our pricing interface. which notice it cannot find it. Part of the reason I made a second folder here was because it couldn't find it. We haven't seen that problem yet, have we? Because it's right here. I can find it no problem. Or if I look over here on the left, it's right here. It's not very far away from our stuff, but it's not in the same folder. So it's in a subfolder, so we do need to import it. We've been automatically importing things. Whoops. I'm in the wrong file. Don't type it there. Back in our Pi one, we need to import it. We've been automatically importing things. Add import for pizza.pricing. I'm going to actually type it at least once. So you should be able to hit Control-Shift-I and it will find it. But our keyword is import, so we need to bring that stuff in. That is actually a copy and paste. When we say import, it does actually go open this text file, copy everything in this text file, and paste it into our other text file before compiling it. All of our languages do that. It just we don't see it. So we need to import. It's in the pizza package. So pizza package dot pricing interface. So it looks like that. That makes sense. It's a file path. So folder / file name. But when we put it in our code, or actually a slash is only for the screen. Anytime you're typing up a file or directory path and put a slash in there, when that text moves to the background to go through the CPU, before running those slashes get replaced with a dot. So when we're actually putting it in our code, we do have to use the dot notation. It is object oriented these days too. So the pizza object, which in this case is a folder, has a pricing object inside of it. And now the error message we kept seeing the other day, we set up some rules. Supposed to have a calculate cost method. We don't have it yet, so we either need to follow that rule or make this abstract as well. I'm going to go ahead and make this abstract so we can see that in different places. We could have just made this an abstract class and put in the concrete methods here, and then what we put in the interface could have gone right here, but I want to split it up to a couple things because it's a class. We want to see the examples. So it's abstract, so we don't necessarily have to create it. We look back at our picture. Looks like we'll have a type of crust. We have add toppings. I didn't fill out the UML diagram, but there's a couple other things some other data fields that should be fairly obvious, right? Cheese and sauce, those are going to come on pretty much every pizza unless somebody's like lactose intolerant, and then they might not want cheese. So I'm thinking a Boolean is probably a good option for cheese and sauce. We'll just do those by default. And then for toppings, we might have one. We might stop with just cheese. We might have one topping, 2 toppings, 20 toppings, any different numbers. So we need a dynamic list. So an actual array is not going to work for us. We need one of our lists that's dynamic and can change size as we need it to. We also need to know what type of crust we have. So I'm going to make a private data field called crust, or private data field of crust type, and call it crust. Well, then, like I just said, cheese and sauce can probably be Booleans because most pizzas are automatically going to have those unless somebody specifically requests not to have them. So a Boolean called cheese and a private Boolean called sauce. And we can just turn those off if we don't need them. And our linked list, no. A good form, we don't want to make it public, right? That would just be bad form to give direct access to that. So it could be private, but all of the child classes of this need their own list. They don't need that inherited list that comes out from the parent. They need their own unique one. So that's where we use the word protect. It's just like private, only the child classes actually get the data field. They get a new copy of the data field, not access to the copy, not access to the actual. I'm gonna go with the linked list. And we need the generic type for linked list. We'll get that in just a second. It's gonna be called toppings. And I'm gonna go ahead and instantiate that to a new linked list. While I'm instantiating things, if we leave it blank like this, there's always a default value in Java. All of our primitive data types have a default value. Objects have a default value of null. Our primitive data types, if it's numeric as 0, so 0 for all the integers, 0.0 for the floating point ones. And if it's a Boolean, the default value is false, but we probably want our pizzas to expect cheese and sauce. So I'm gonna go ahead and change that default value to true. We'll go ahead and set that up. Instead of doing it in the constructor, we can just do it here overall. It's fairly common to do this one right here. Go ahead and assign the linked list to a new linked list. Because when we start doing things, we won't be changing the linked list, right? We'll be changing what's in the list, but not the list itself. So it's fairly common to go ahead and instantiate that. And then when we get to the constructor or our methods later, then we add and remove things from that list, but we never actually change the list itself. We need our generic type. We also need the import. I'll type it in again. So import, include from something else. In the basic Java language, we have the util package. So the Java package has a package called util for short for utilities. All the tools we might need are our most common tools, and one of those is going to be a linked list.
I don't mean to bother you, but the second linked list is not the same.
Oh, thank you. Yes, please point that out anytime you see that. Typos happen when we're completely focusing all of our attention on typing, and I am standing up here talking and typing at the same time.
I hadn't even noticed it really.
Would have noticed it eventually because there's going to be an error message for a minute here. It's imported, but it's still underlined. The problem is that generic, right? We talked about generics the other day. This isn't a generic that we're making. This is a generic that's that was already in the language. Doesn't know what type of thing to put in the list. We could use object, and then anything we make can go in the list. But that's really bad form because then they're not objects, or they're not the thing we actually want there. It's just objects, so we have to cast them later. So it's bad form to do that. So we really want to put something in there. It's going to be a list of toppings, so I'm thinking we need a class to represent all of our toppings. So toppings are different than the pizza itself, right? Something completely different. So if we look at the package names, we have the pie. So this is like the crust, the pie. And the only thing we need about toppings is the list of them we bring in. I'm gonna make another sub package for that. So I'm gonna come back up here, click on the pizza folder. That's really what it is. I guess I should say package, but the one that's a folder, and right click and create a new folder, which if we highlight that, also the new button. Folder is an option here, which I think is all the way down under other. Yeah. Scroll all the way down to other, and then all the way at the bottom is folder. So. Make a new folder, and I'll call it toppings. Because every one of our toppings is gonna be different. There's a lot of customization involved there, right? It didn't make the picture, did it? Yeah, we're off the picture for a minute because we need a bunch of toppings. And we have to create those classes. So I'm going to go ahead and create them here. We can kind of see something from the picture. It's implied here. I guess toppings are way down here, right? Oh, this is once it's applied, the different types of pizzas. But that's where our interface needs to go. They're gonna have different prices, but I think pepperoni is more expensive than green peppers, right?
I think so. It's a meat.
Yeah, a lot of pizza places charge the same for all of them, but other pizza places, it's different for the topping. And those are usually better ones. Better pizza places charge different amounts per topping. So if we go to that folder and create a new Java class. Call it topping. And this is where I was planning on putting the interface. Go with that. Okay, done. I was did this example last year. I put it in by when I was thinking about it a few minutes ago. This is actually the one I was thinking about putting that interface on, because our toppings dictate the price. The crust probably has a base price to it. So we'll do a selection structure where if it's a deep dish, it's, I don't know, $17. And if it's thin crust, it's $14. And then we increase that price based off the toppings we have. So each of our toppings is what needs to implement the pricing interface. Implements pricing. And this time I'm just going to do the Control-Shift-I. Instead of typing it in directly, just hit Control-Shift-I to do all of that. And again, topping would be an abstract class. At this point, I don't think I have anything that needs to go in this class. It's just a name to help organize all of our toppings. We'll have some specific things that go into like the pepperoni or the green peppers or the onions. Those will have unique things. If we weren't under tight time constraints, there were probably some things that all toppings have in common, right? But I think all of the details will go into other stuff. But this is what it needs to be. The reason for making this abstract class here is another very common one. Because we started doing that because we were making our basic pizza pie class, the one that's going to be the parent of the actual pizzas. Has the crust, the cheese, the sauce, and the list of toppings. But we have to be specific. So if we said it has a list of pepperoni toppings, that's only going to work for pepperoni. Or a list of green pepper toppings, we're restricted to only that one topping. So in this case, there's a parent class that doesn't have any code in it. All of our toppings are going to be inherit from this class. There's nothing to inherit, but they will be a child of it, which means polymorphism will apply. So if we use this as our type in that list, then whatever topping we have can go in there. Does that make sense? You see how that's why we need the abstract classes. It doesn't do anything. This one explicitly, our other abstract class is actually going to do something. If we look back at the picture, it actually has a method. So there's going to be stuff to inherit from the other one. But in this one, there's nothing to inherit. We're only doing this for polymorphism, and we'll make everything else a child of this. And that way, when we have to get into our strictly type part, we can just use this abstract one. It's just for that. It's just the abstraction of all the types we actually want to use. So that when we're over here and have to put something in our linked list, we can say we want a topic. Which again, we have to import. Control-Shift-I should find it. But we can, so just to make sure we see at least once where those come from. We're going to import some other code. And we want to import pizza.toppings with a lowercase t dot topping with a capital T. The pizza package, or I'll say folder. The pizza folder has a toppings folder in it. And that's where we will find the topping.java or topping.class once it's all compiled. I said copy and paste. It copies and pastes from the compiled version, not the text file version. Hopefully that shows kind of the two places we're going to use the abstract class. We don't have all the details. We can't fill in details here, so this one has to be abstract. We know most of the things about the pizza, but we don't know what the pizza, we don't know the fine details on any particular order. When we actually make a pizza off of our design here, we don't know the fine details. That one needs to be abstract. And then topping, we have to abstract that so that we can refer to the type of it. Now we need some methods. We'll come back to the toppings class. So we go over to the pie. And I'm just going to put in the default constructor. So alt insert is the generator in NetBeans, so constructor. Uses a generator. We could do more constructors. You can go ahead and generate more constructors if you want. You may have noticed there the only option we have to pass something in is a crust. But if you think about a pizza, anybody ever worked in a pizza place? If you think about when they order, I'm sure everybody's at least ordered pizza, right? They're going to ask those questions later, and they don't really care what order you give them to them. Yeah. They don't care whether you say you want deep dish pepperoni or pepperoni deep dish. So getters and setters will probably be a better situation. Better for this situation. We start with just a blank pie and then use our setters to apply all that stuff. So alt insert and go ahead and generate all of our getters and setters. Select all of them and generate that. Alt insert. We always want to do the toString method. Cost here. I didn't have that in my example. Oh, last year I didn't do the toString method. As I was doing this, well, let me go ahead and I'm going to come back and redo this. So if you want to stop following for a second, generate this, and then that's going to look like the receipt, right? Crust, deep dish, cheese, true, sauce, true, toppings, pepperoni, green pepper and sausage, jalapenos and, more spicy stuff and anchovies. Salt would be really, really good with all that spice. It's, it'll look like that. So on that string, we might want the price as well. That's something else we probably want all of our pizza pies to have is that price. I'm gonna make it private. This would probably be better if it was protected. That way we could change it in the later one. Actually, I'll do protected. I was gonna show you something that looks really, really messy in the code, but we can do, so I'm gonna do protected. Actually, I'll type this up, so if you wanna stop following, I'm gonna replace this with something nicer in just a moment. If you made it private, double price. Then we need a private decimal format. Have we seen that? We've seen decimal format? Okay, as a new decimal format. It feels like we haven't seen that. So there's lots of ways to format things in Java. With money, we could use the geolocation of the machine. That's a really nice one. There's lots of currencies. I think we've used this. So this is a common one. We need a pattern to say what it's going to look like. Oh, okay. So, oh yeah, that's right. Yeah, we have seen it. So we have all of that looks like normal Java syntax, and the parameter we pass in is a string, and we put a 0 if that digit is definitely going to show, or a hashtag if the symbol is optional. So like 0 point hash will show the digit before the decimal, and then 2 digits afterwards if there's 2 digits afterwards. It might drop them, they're optional. If we did hash.00, if we have a whole number part, it'll show it. Otherwise, it might not even have a leading 0 because the optional part is before it. Could make all 3 of them optional. Hash. And then if there's an integer part, show that. The ones to the left automatically fill in. Bigger number, we just need at least 1 on this side of the decimal. It's money, so I'm thinking we probably want all 3 of those to be definite, right? So 0.00 definitely include at least 1 digit before the decimal and always include 2 digits after the decimal, and this does round. So we'll need that. Then we need to import it. Control-Shift-I. You can see where it's at. So java.text.decimal format if you would just rather type everything in. What's that underlined? Oh, I forgot a name for it. DF is a good name for decimal format. And then from that, we'll call a format option so that our price only shows those many digits. I'm gonna erase this code here in just a second. So then we set up our getters and setters, right? There's no thought involved. That's why we have the computer type them. Getter is just returning the value, and setter is just taking a parameter and put whatever parameter is passed in that value. So when we call it from our other code, we'd have like our object dot set price, and we'd set the price to object dot get price. We want to get the current price plus whatever more we add to it. That's a very common thing to see in our code. We can get around it. I was thinking about typing that, but I think I'll do it. I'll do it a different way. If we set it to private, we would have to do that. We'd have to use the getters and setters to get back to the one that the child classes inherit, which when the child classes inherit those private data fields, really what they get is access to them. To use the analogy, parent-child analogy, the children have access to the one their parent has. they have access to their parents' stuff. Whoops. So, in this case, the child classes, whatever concrete class object is made from, here in a few minutes after the break, whatever concrete class that's made from has access to the parents' price field. But what we want, instead of doing that mess, but I did want to actually look at that. Does that code make sense? You'll see that all the time in Java because of that. An alternative is to make it protected. Because when it's protected, to use that parent-child analogy, instead of just letting the children use the parent's item, maybe it's like a concept, and the parents teach the children how to do it. So then the child class has its own price. It doesn't have to go back up to the parents. So let's do that this way here. Which is a change from my plan or what I did last year, so we might hit typos somewhere along the way. Then I guess we need a getter and setter for that, and add it into our toString. So we do Alt Insert, getters and setters. There's only one thing we've added since all the other ones were generated. So add that in, Alt Insert, toString, include everything, and do some editing here now. Let me get the Zoom thumbnails out of the way. That'll be out of the way. So we don't actually need to print out the decimal format. That's just a little bit unnecessary to print that, I think. So we set to double quotes. We've talked about that before, right? Single quotes and double quotes are not interchangeable. The generator made that a character instead of a string, but since everything else there is a string, I mean, and we're turning it into strings, I'm just going to make that a string. And here's what we want to apply that formatter to, right? So right before, if we say df dot format, and you can see here in the predictive text format, and then the object we want formatted, or in particular the double that we want formatted. We probably want that second one there. So df dot format, and then put some parentheses around price. And then that'll give us that format we set up, which is however many things we have on the whole number side, the dot, and then definitely always show two places afterwards. Zeros are required, hashes are optional. And anything to the left will automatically fill in. If you need more, it'll fill in to the left. So you can think about just to the left, there's always hashes. They'll just fill in as needed. Everything about that class makes sense? That should be everything for our pizza except the instructions on how to add toppings. So we want a public method. I'm not going to return anything because it's just adding things to our list. And it's going to be called add topping, which this was on the picture. This is add topping. So we need that. Oh, I jumped ahead of myself. Adding a topping at this point is a little difficult because we don't know what we're adding toppings to, or we don't know what our toppings are, right? We don't have the details for how to add a topping. We know that we will definitely be adding toppings. We just don't know we just don't have the details of how we add those toppings, right? So this should probably be abstract. We know it's going to be there, but we don't know how. We don't know enough details to do that yet. Actually, I'm going to I think I typed this in the wrong spot. I did that in last year's example and was looking at it, but I was actually thinking about putting. That goes on the particular type of topping, right? I'm gonna take that out of here, because that's the detail we don't know. We don't know the price, that's why we can't fill this in. So then we're seeing all of the stuff in a different setting. We have an interface and an abstract class, so we have two different sets of rules for how we can configure our types. We have the abstract pi class, which everything will inherit from, and implement this add topping method, which add topping is obviously going to apply toppings, and topping implements that interface. That's what I had in mind when I drew the picture, but I typed it in the wrong spot. Apparently last year and was just copying from that earlier today. But we've already gone off on that. We've already done stuff different than what I did last year. And then we'll use that requirement, or was it? That requirement that all of our toppings have a calculate cost method, which will then, that is what we will use to calculate the price of our pizza. Maybe I should call that cost. That would be a better name, right? So our method is, our requirement is called calculate cost. So I'm going to rename that. And there's a lot of places to type that already if we go to retype it. So usually what we do is right click on it and refactor. And then have the computer retype that for us. So under rename, can change price to cost. And you can see the checkboxes of, if there's any comments, we don't have any comments, but I'm gonna click that anyway. Right, if you have Java comments, you definitely want to apply the name, change the name there as well. And we do have getters and setters, so I want to click both of those and hit refactor. And have a new name there. Our getters and setters updated. And our toString updated. So instead of having to type that in every place, you always want to make sure and refactor. Now that we've seen that a couple times in this class, I'll go ahead and say that is one of the first things you want to learn anytime you encounter a new IDE is look around or Google and make sure you know how to refactor, where the refactor button is. It will be very, very important because retyping, you're probably going to miss stuff and make typos, right? That's how humans are. So we have our abstraction. Our abstraction's in place, but we need the concrete version of it. We can't actually make any objects yet because all of our objects are abstract. But it looks like it's good to have program, right? 10 minutes sound good to everybody? So my laptop says 7:14. So we'll get back to it at 7:24 with the concrete version, making some of that abstraction concrete so that we can actually implement those in our code. I'll see y'all in a moment.